Good morning, guys. No, it's rather good evening, guys. This is a Casio clock and it has stopped working because the battery that was in it leaked, and I did open it up and clean it, and still it wouldn't work. It worked for a while and then it stopped, but it actually corroded one of the contacts inside. I will open it up and then I will solder the the contact where it was corroded and see if it works. And just to show you, see the battery value here, if you can see it. It's okay, it's more than 1.58, so the battery is fine. And if I insert this battery in the clock, as you can see, it's not working. So we need to now open up. So these are the screws, 1 2 3 4 screws that need to be opened. I'll just open these screws. So I have opened all the screws here, and we can now remove the glass from the body. Just keep this aside, and then we need to remove these second hand. There's a crude way of doing it. I think there are tools which you can use, but I'm just using my fingers. Put that side aside as well. Now we need to get this mechanism out of the body, and as you can see, they are held together by these clips, this and this clip. So just a little pressure on these clips and we should be able to remove it. See, so the mechanism is out, so we'll keep this aside as well. Now this mechanism is held in place by clips here and by a clip here, so you know where things will go. So just a slight pressure and lift it a little. Pressure on this side will open this clip as well. So yeah, so this is out. Now the first thing you need to do is you take a photograph of what you are seeing, so that when you reassemble it, you know what is where. There are certain things. So okay, so we'll remove these gearings now one by one. Which is held in place like this. Now a few interesting facts about these quartz mechanisms. This is the oscillator here. There's a quartz oscillator in here, and this vibrates at 32.768 kilohertz or 32,768 hertz, which basically in layman's language means there is a quartz crystal. When an electric current is applied to it, it vibrates at 32,768 times per second. Now this frequency is so accurate and it is so consistent that it is used as a reference for 1 second. So how is that done? If you divide 32,768 by 15 times consecutively, you will reach the number 1. So that is then considered 1 second, and this magic is done by the electronics in the watch or clock or whatever you have. So that then becomes 1 pulse for 1 second, and then the gearing mechanisms does the rest of the thing. So you have like 60 seconds, then 1 minute, then 1 hour, and what have you. So that's all done by the gearing mechanism. Now the question you could say is, why are they using just 32,768 hertz? So the question is, why don't they use a crystal that is less than this 32,768 hertz? The reason is our hearing range is 20 hertz to 20 kilohertz. So we can hear frequencies that vibrate 20 times per second to 20,000 times per second. So if a watch crystal is between say the 20,000 range or below that, we will all be hearing a whining noise when we wear these electronic watches which have this quartz crystals or oscillators inside them. So that is why we use this frequency which is beyond 20,000 hertz, so that it's not audible to our ears. As you can see, this blackish corrosion, this is what I think happened when the battery leaked, and it just kind of corroded this. So you can see this terminal is corroded, and when we put this mechanism where it should be and see what this corrosion, this is the corroded terminal. So this terminal is actually for this contact, and this is the negative terminal of the battery, as you can see here. So this is the reason why it is not making a proper contact. It has corroded here. So what I'm thinking of doing is I will apply a slight layer of soldering here so that this becomes repaired, and then we'll put in the battery and see if it worked. So let me just get my soldering iron in place. Okay, so I have this soldering iron ready, and this is a little flux that I will apply here. So I'll just put some flux here. The flux helps in the soldering of two different metallic surfaces. So as you can see, we have put a layer of solder on it, and now we need to clean this flux. So for that I will get a contact cleaner and get this clean. So the reason why we need to get rid of this is because this flux is quite corrosive. So let's get rid of any excess. If you don't have a contact cleaner, it's okay, you can use 99% of isopropyl alcohol as well. That will also do its job. So I'll just get rid of any excess here. Spray should do the trick, cleaning everything up. Okay, another interesting fact is this is a permanent magnet, as you can see, and this is a gear that shifts that second hand, and so basically it just comes here. And the funny thing is, if you apply current to it, so this goes in 1 second, it goes in one direction and then it flips to the other direction as well. But the thing is, then the question is, why does it keep going? Why do we have the second hand moving in one direction only? Why doesn't the second hand go in one direction and then flip back into the other direction? The reason is electromagnetic coil here, and this iron strip here. So when it gives it a signal or a current, electric magnetic field is created between these two poles, and this magnet, permanent magnet, will align to that magnetic field. So what happens is, it does not actually come and stop at the complete alignment. It is offset in a little direction away from its original place where it should actually be coming to a stop. It is kind of offset, and that is the reason that when it has to move in the opposite direction, it just tends to move forward in one direction. I'll clean up any moisture that's still around, because that electronic spray comes from a high pressure area into a low pressure area, and it becomes cold, and because there's so much moisture, all that moisture condenses. So that needs to be get rid of. Now what I will be doing is, I will be lubricating the parts of this mechanism with the oil. I'll be using this oil, which is pretty expensive. But anyway, and you don't need a ton of it, so just a little is required. So you just kind of wet it here, and either you can just touch it at the mechanism, just a little. You don't need a lot of this oil. It just kind of helps lubricate the mechanism, and most of the work is then done by surface tension, so the oil is then wherever it will close, it will require this. A little oil on this as well. So this is the moving part. Some maybe on the gears. Like I said, we don't need a lot of it. Okay, so this is the gearing mechanism that is driving everything else. I'll just put that there. This will go here, and this will go in here. And now we need to put this mechanism as well in place. Right. So this is in place. As you can see, it is going in one direction and then flipping in the other direction. Can you see that? So it is going in this direction and in the other direction. But the clock moves in one direction, and that's because when an electric current is applied to this coil, it creates a magnetic field, like I said, and this permanent magnet wants to align with that magnetic field, but it is slightly offset from its position where it should stop, and that's the reason instead of going backwards it just goes forward. And now we can lubricate the remaining things, remaining gears. So I'll just lubricate a little of this. This part is going here. Okay. This goes here, and this goes here. So this is it. Hopefully we have put all the gears in place. Now we just need to close this, and so let's see, keep it steady. I'll just put in the battery and see if our hard work has paid off or not. Right. So anyway, let's try. Yes, you can see this moving. So we can test it by just putting the second hand, and yes, we have it moving. So we just now need to close the whole thing. So now I just need to reassemble it. So just squeeze it in one of the slots first, and then press it back. There you are. So this is done. Now we need to put the hands in. Thing to go is the hour hand. Try and align it with 9 o'clock or whatever you have, and press in here. Don't press anywhere. Press it around the diameter where you're going to press it. And then we have the minute. So this has to be aligned to the 12 o'clock position, so that it's a complete 1 hour. So when you got that, so press it along the diameter and nowhere else, because if you press it somewhere else, it will. Okay, now just let's see if it is properly done. So when we make it 10 o'clock, it should be exact 10. Yeah, I think it's perfect. It's okay. 11 o'clock. Okay, and then the second hand can be put, since it's Yeah, so that's it. And then we put in the glass. And just figure out where the 4 holes are. So that's it. And put in the screws, and then we will put in the battery and check it once more, and hopefully it works. So I'll just put in the screws back. So the moment of truth has arrived. We have reassembled everything, and now I'll just put in the battery. That's negative terminal, and that's plus is the positive terminal. Got that? Okay, so we'll just put in, this is, as you can see, the battery here as well. So that's the positive terminal of the battery, and this is negative. So we align it properly and then have a look and see. Okay, so we have thankfully fixed the clock, and is if you have a clock or a watch which is running on batteries, it is always a good idea to change the batteries well ahead in time, because in this case what happened is it had slowed down, but I became a little complacent and let it go on, and ultimately the clock stopped working. And I then, when removed the clock to change the battery, I realized to my dismay that the battery had leaked, and I then had opened it. I cleaned all the mechanisms with the contact cleaner. You can use isopropyl alcohol as well, but that fixed this problem for a short while, and then again it stopped working. Then I realized what the problem was, because I had seen that corrosion on that circuit, which had completely corroded the contacts. So I made this video to solder over that contact so that the battery terminals are properly seated on the circuit board. Now it's always a good idea to change your batteries well ahead in time, otherwise you will have leaking batteries, and this goes for any electronic equipment that uses a battery. Do not leave batteries inside your devices if you are not going to use them for a long time. It could be your camera, it could be anything that requires a battery. For clocks as well, if it is slowing down, if you think it's running short, then you know something is wrong with the battery, so replace that immediately. And another good tip is write the date on the battery before you insert it, so you know how long it has lasted or when last time you changed it. The Quartz watches are so accurate. Even the cheapest Quartz watches will give you an accuracy of about plus or minus 5 seconds a month. If you compare that with even the most expensive manual watches that use mechanical gears and stuff, and they don't have a battery in it, their accuracy is about 5 seconds plus or minus in a day. So these devices, these electronic ones, are pretty accurate and quite reasonable as well. So still working. We'll hang it on the wall and see how long. I hope it lasts. Thank you.